but just like with the sign analysis, so the idea here is we're going to utilize the graph of f prime to analyze function properties of y equals f of x. So for example here, just give you a basic example. You have 1, 2, 3, 4, 5, 6. Go right through here. 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 Now, something that needs to be very much noted is that without explicitly being given a point a f of a, we cannot determine function values. And we will get to that point where we are given values of a, f of a, outputs. But not right now. So I get a lot of mistakes in people saying like, oh, there's a maximum at, and they give me the x and the y value. All right. That isn't the y value. That's just the value of the y value of the derivative. When thinking about the sign analysis, we always have to remember that we're not necessarily interested or worried about the actual value of the derivative, but we are more importantly interested in the sign. If the sign is positive, if the sign of the derivative, so now it is important to know the values, and are they increasing or decreasing is also of importance. Now in this graph, I'm also going to tell you that there are horizontal tangents at x equals 2 and x equals 4. Now note that I explicitly say this because we don't want to eyeball it. So on the AP exam, this will be explicitly told to you. And it's just to confirm, because they're like, oh, it doesn't look like it happens right at x equals 4. But I'm telling you that that graph right there, the horizontal tangent, in other words, where the graph of the derivative changes from increasing to decreasing, is the horizontal tangent. Now, also to note is that, remember, the slope of f prime is the value / sign of f double prime, i.e., if f prime is increasing, then f double prime is positive. All right. Now, there's a lot to try to, you want to talk about the analysis of the function. So one of the properties that can be very helpful, now when we were talking about is the function concave up or concave down, we look to the sign of the second derivative. But what this tells me, so f is concave up when f prime is increasing. F is concave down when f prime is decreasing. And the reason there is that, you know, f prime decreasing equals f double prime negative. So when we were doing our justifications, and we should still rightly do so when we're doing function analysis analytically, that concavity is determined by the sign of the second derivative. Or the sign of the second derivative tells us the concavity of our function y equals f of x. Now that is still true. But the fact of the matter is, on these problems, you're going to be given the graph of the second derivative. So as such, when we talk about our justifications, we should talk about it in the justification of f prime. Now, if you still choose to say f double prime is positive versus saying f prime is increasing, that is valid as well. So you just have an extra ability of how to say and explain it. In graphs, I like to just have all my justifications with f prime. Now, of course, it seems to be a lot to remember. So we have a little table here to help us remember, and it's f, the properties of the function f prime, and f double prime. Now, these functions, f prime and f double prime, which are all, remember, functions, they could be positive, negative, increasing, decreasing, concave up, or concave down. Now, the function f, these properties are basically what we want to know. Now, as I've kind of also instructed you, f prime tells you nothing about the specific value of f. Okay, that is shown by this part right here. F prime cannot tell me if a function f is going to be positive or negative just by the sign of that derivative. Now, how do I know if f is increasing? If f prime, and then we can just shift everything over, is positive. How do we know a function is decreasing? If f prime is negative. How do I know that a function is concave up? When f prime is increasing. How do I know a function is concave down? When f prime is decreasing. Similarly, f double prime, and this is more so for tomorrow, but also helps us with today. F double prime doesn't tell me anything about the sign of f or f prime. F double prime does not tell me anything about the function f increasing or decreasing, nor does it tell me anything about f prime being positive or negative on its own. However, if f double prime is positive, it tells me that f prime is increasing, which means that the function f is concave up. And if f double prime is negative, this tells me that f prime is decreasing and that f is concave down. So, as such, just as a reminder, f has a relative min at x equals a if f prime changes from negative to positive. F has a relative max at x equals a if f prime changes from positive to negative, and f has a point of inflection when the function changes from concave up to concave down, at x equals a, when f prime changes from increasing to decreasing or decreasing to increasing. Relative extrema on f prime. All right. So if f prime changes from increasing to decreasing or decreasing to increasing, that's a point of inflection for the function f. Why? Because if we look over here, we know a point of inflection is defined in its most definitive definition as when the function changes from increasing to decreasing or concave up to concave down, or concave down to when it changes concavity for the function f. In our previous justifications, we noted that that was similar to when f double prime changed sign. Well, now we have this new one right here, that there's a point of inflection, therefore, for the function f if f prime changes from increasing to decreasing or decreasing to increasing. Now, when you look at the graph of f prime, that means if you see a relative extrema on f prime, that's a point of inflection. Now, you cannot be making mistakes that are very simple, such as this. If I asked you, where is there a relative extrema for f? The worst response that I can get from you is you go, oh, there's a relative max at x equals 2. No, this is the graph of f prime. This is the graph of y equals f prime of x. So there's a relative max for f prime at x equals 2, but there is not a relative max for the function f of x. We should realize that for f, this right here is actually x equals 1 will be a relative min. X equals 3 will actually be a relative max because the derivatives sign change. X equals 5 will be a relative min. X equals 2 will be a point of inflection. And x equals 4 will be a point of inflection for the function f. Remember, the whole trick here is that you're analyzing the function f, the properties of the function f. In this case, though, you're not given the equation of f or the equation of f prime. You're given the graph of f prime. Okay? And the same thing happens with intervals. So when the graph is above the x-axis, let me be more specific. When the graph of f prime is above the x-axis, that means f prime is positive, which means the function is increasing. Okay? Now, on the AP exam, you could be given a curved function like this. All right? And in that case, you're just trying to identify, for example, a common multiple choice question is, given this graph, how many points of inflection and how many relative mins and how many relative maxes? And you'll be given, a combination of there's 2 points of inflections, 2 relative mins, and 1 relative max. And that would be the answer. Sometimes the question will be, where is there a relative min, relative max? Sometimes the question will be, over what intervals is f prime concave up, concave down? Now, we could do this one as the example, but I was trying to annotate with all the notes and to kind of pinpoint all the stuff. So let's look at a graph that was very similar to when we talked about particle motion, where we have lines, and therefore we can calculate slopes. And that's the one we're going to do. So I'm going to make this next one as a graph, and it's the one that we're going to really work on in terms of the problem. And I'll give you some time to copy it down. So here's the example. One, two, three, four, five, six, 7. -1, -2, 1, 2, 3, 5, 6, 7, 8. This graph has a point at 0, 2, at 3, 5, at 4, 0, at 5, 1. Now notice I'm telling you these coordinates because there's not like a grid, and so sometimes the point, just to make sure that you're eyeballing it where you're putting that point a little bit better. 6, 0, 7, -2, 8, -2, and we're just going to combine these like it's a, connect the dots. Keep going like this. This is the graph of y equals f prime of x. And I also note that f of 1 equals 4. Now, I gave you a function value, and I'm going to show you how we can use that function value in a little bit. So these are some really, there's a lot of things that we can do for this problem. So I'm going to pause real quick. Now, this is a very common AP exam question. And we're going to do some problems that are actually, before we get into like the function analysis problems like you've been seeing them recently, let's do a couple of common problems. The first question, very common, find f prime of 1 and f double prime of 1. Okay. How do we find f prime of 1? Can somebody speak up? Maybe, if you can't find what is f prime of 1, or you're having problems making sure that that's the answer, how would I find f prime of 1?
Isn't it 0 because f of 1 is 4?
So that was a weird response because you gave me the answer, but you gave me the wrong answer. You gave me the right answer, but you gave me the wrong answer. So you said, can you just repeat it just to make sure I heard it right?
I asked if it was 0 because I see that f of 1 is 4.
No, okay. I think you said 3 beforehand.
No, I didn't.
Oh, okay. So f prime of 1 is simply the output of f prime graph. We're given the graph of f prime of 1, of f prime of x. So f prime of 1 is that value right there. Now, of course, if you look at that, the way I'm doing it is I'm eyeballing it, right? Which is something we never want to do. So one of the things that we want to do and make sure we do is calculate the slope. So in this case, the slope here is a rise of 3 and a run of 3. So what is the slope right there for that section of the graph? What is the slope for this section of the graph? What is the slope of this graph?
For one,
It's 1. The rise is 3, the run is 3, therefore the slope is 1. We just started from the output of 2. So that means that this went over 1 and 1 exactly, so that leads me from getting the value of 2 to 3. So therefore, f prime of 1 is what? F prime of 1 is, read the graph. It's right there. Just the output.
8.
There's no 8 on my graph. Right there. Read the graph. This is easy. This is straightforward right here. F prime of 1. What is the value of the output of the graph at x equals 1? This is a middle school question in essence at this point. What is the output when the input is 1?
It's 3.
It's 3. When x is 1, the output is 3. This is the graph of f prime. F prime of 1 is 3. This is the graph of f prime, people. This is the graph. So the outputs of this graph is the output of f prime. So for example, and I didn't say it, but what is f prime of 3? I'm not asking the question in terms of the actual question, but we'll answer it right now. What's f prime of 3?
5.
5. What's f prime of 4?
0.
0. So the outputs are the values. It's as simple as that. You're reading a graph. It doesn't matter if I call the graph f or if I call the graph f prime or if I call it whatever. The values of the graph are the values of that function, and that function in this case is f prime. F double prime is simply the slope of f prime graph. So f double prime, and we've already found that, so f double prime of 1 is 1. F double prime of is 1 because that's just the slope, and we just found the slope right there. The slope of that section of the graph is 1, and that represents the value of the second derivative. Now, it should be noted that, and I just wanted to note here that f double prime of 3 is undefined because you can see that there's a sharp turn right there. Based on this graph, f double prime of 3 would be undefined at any sharp turns of the graph of f prime. Now, when you do this though, it's also, you may want to show the quotient. So f double prime of 1 is equal to 5 minus 2 over 3 minus 0, which is 3 over 3, which is 1. In other words, you want to show the calculation of the slope. I have seen some AP exam questions where they actually want you to show the calculation. So just to be careful, you'd want to. Now, this problem is kind of obvious in calculating the slope is 1, so they wouldn't ask you to show work, but at times they do. So there's when calculating slope, it's a change of y over change of x. That's what we refer to as the quotient for the slope quotient. Um, it's something that you'd want to do, but in a problem that this straightforward, they're not going to require it. But so f prime of 1 is 3, and f double prime of 1 is 1. All right, let's do a review question. You have all the information to answer this following question. Example, or part B. Find the equation of the line tangent to f of x at x equals 1. Tangent lines. We just had this whole thing about when you guys were struggling to find tangent lines and what was the formula and how do we write those. So, it should be better now. I want to find the equation of the line tangent, the tangent line, the tangent to f of x at x equals 1. How do I start by doing this problem? How do I start it? When I read tangent line, find the equation of the line tangent, I should be automatically thinking what and writing down what?
Y minus y1.
F of 1, I'll go F.
So is the other one f?
Oh, you're missing something.
Equals f prime of 1. Multiplied x minus 1.
Very good. All right. So what's my answer?
Y minus 4 equals 1.
Nope.
Oh, it's not 1. It's 3. Yeah, x minus 1.
Okay. So you can still do tangent lines for these type of problems. Okay. Now, notice that that's the reason why this point was given. The fact that I told you f of 1 is 4 was only because it needed to be used for the tangent line. You needed to know what the output value for the function f was at x equals 1. Without that, you could not have found the equation of the tangent line. We'll get into things about linear approximation a little bit later on. I don't want to cover it right now, so we're gonna move to your more common question. C. Find the x values of relative extrema. Identify, type, and justify. All right. Where is there a relative extrema? And I should have noted this, of f of x for y equals f of x. So looking at this graph above here, where is there a relative extrema for y equals f of x?
Is it at 5?
No. That's what I was referring to as when I said earlier, it is the number one mistake that you cannot make. That's a relative extrema for f prime of x. These type of questions, when it comes to the AP exam, it could be one of the easiest questions possible. I find it one of the easiest questions because it's either you know it or you don't. And of course, today you're just learning, so it's okay to be wrong today. But this is one of those questions that after today, you cannot ever get it wrong if you plan to pass the AP exam. So one of the things I would know is that I know the answer cannot be x equals 5, and that usually helps me remember what I need to do. So where is there a relative extrema for x for y equals f of x? Ariana, you're correct. The answer is x equals 6. Right there, there's a relative extrema. For the function f of x, which we don't know what it looks like. We don't have the graph of f of x. But given the graph of f prime of x and the property and the signages of f prime of x, we know what f of x will do. Now, what kind of extrema is it at x equals 6? We have a relative what? I asked you to identify the type. So is it a relative minimum or a relative maximum? It's a relative max because it's a relative maximum because f prime changes from positive above the x-axis to negative. The relative max, right there. Just like the example I gave over here, when the derivative changed, when it went the derivative from above the x-axis, meaning the derivative was positive, to below the x-axis, which means the derivative is negative, we have a relative max for y equals f of x. So relative maximum for the function y equals f of x right there. Now, I do want to point out right here, this is neither, but I do want to note that there is a horizontal tangent right there. There's a horizontal tangent for f of x there and there. So there are two horizontal tangents. But this horizontal tangent, it's a critical point, but it's neither because the derivative does not change signs. This is a horizontal tangent, and it is. When thinking about the graph on this one, this graph is going from increasing, it levels out, and it goes back to increasing. All right, so you can see that there's a horizontal tangent. This part of the graph is going from increasing, and then the graph is going to be going down to decreasing. All right, we'll study about the graph part of it on Thursday in terms of working to try to graph the properties of a function given the derivative. D. Find when y equals f of x is concave up. Justify. And sometimes we'll note this one for 0 less than or equal to x less than or equal to 8. All right. So most of the times when we do these problems, we want to close off the interval. So we're only worried about from 0 to 8. So yes, this graph over here, there is a part of the graph over here. We really don't care about it. We're only really looking at the graph from 0 to 8. All right, so my answers are only going to be from the intervals 0 to 8. So when is a graph concave up? Well, a graph is concave up when the what? When what is true about the derivative? What's the justification? Looking at the graph of f prime, a function is concave up when f prime is what? F is concave up because f prime is what? A function is concave up when f prime is what?
Increasing.
Yeah, increasing. So a function is concave up when f prime is increasing. So, knowing that, looking at this graph, going only for 0 to 8, when is the derivative increasing? When you see f concave up, you have to think f prime increasing. So what's my answer? What's my answer? No. That's when f is increasing. We want to know when f prime is increasing. It's definitely not a coordinate. It's intervals. We should always know. Now, one of the biggest things that you cannot be making this mistake. When we talk about when in function is increasing or concave, or talk about when there's a concavity, the answer is an interval. So if you give me the wrong interval, that's okay, problematic for today. Do not give me a coordinate. That is way off. That is very worrisome if you think it happens at a point. Concavity happens over intervals. When is f prime increasing? Because that's when the function is concave up. Let me put it in easier terms. When is this graph increasing?
Is the first interval from 0, 3?
Yep, it is. Is that it? Is that my whole answer?
Um, is the other one from 4 to 5?
Yep, union 4 to 5. And the reason why the function is concave up is because f prime, that graph that we were given, is increasing. There is the function f is concave up when f prime is increasing. When is f prime increasing? Well, this is the graph of f prime. So when this graph is increasing. That's it. And you can talk about concave down, 3 to 4, union 5 to 7. Last question, I guess I have to do this on a separate page. Find the x values for f that are points of inflection. Justify. Well, what is the always you got to go back in terms of what is a point of inflection? A point of inflection occurs when the function changes concavity. Okay. Well, I don't have the function. I have a derivative. So a point of inflection happens when the derivative changes from increasing to decreasing or decreasing to increasing. Also known as when there was a relative extrema for f prime. So looking at this graph, where are the points of inflection for f? I kind of gave you a hint in that I use a plural vocabulary, which means there's at least more than one. And please make sure to tell me x equals. Do not say just a number because you got to make sure that it's x equals, not if you just give me a value that could be referring to an output. So where are their points of inflection? For f of x, given the graph of f prime of x. I want oh, no, that is not one of them. These are the easy questions, people. Looking at that graph, when does that graph change from increasing to decreasing or decreasing to increasing? A point of inflection happens when the derivative changes from increasing to decreasing or decreasing to increasing. You are given the graph of f prime. So when is that graph that you are given changing from increasing to decreasing or decreasing to increasing? Yes, we got a response. That's correct. X equals 3. X equals 5. No, actually, no, those are not all the right answers. So X, I'll give you the first one. X equals 3. Okay, X equals 3 is one of the answers. This is one of those questions where you either get them all right or none of them right. So if you only gave me one and there's a lot more than one, then you get 0 credit. If you give me a wrong answer, you get no credit for the point of inflection questions. So if there's 2, you have to get both of those 2 and only those 2. If there's 3, you got to get those 3 and only those 3. You can't get any wrong ones. You can't miss any of them. Okay, so x equals 5, and I was writing that down, is another one. I wanted them to write them in order. There is one more point of inflection. And this is what I mean. You need to get all of them. And the other one is x equals 4. There's right here, there's a relative max. The function changes from increasing to decreasing. I can't state the simplicity of this graph right here. When does that graph change from going up to going down, down to going up, increasing to decreasing? Right here, point of inflection. Right here, point of inflection. And right here, point of inflection. This graph of f prime changes from increasing to decreasing at x equals 3 and x equals 5, and from decreasing to increasing at x equals 4. Those are my points of inflection, and the reasoning and the justification is that f prime of x changes from increasing to decreasing and decreasing or decreasing to increasing. Technically, you know, that's where it goes increasing, decreasing, and that's where it goes from decrease. You don't really have to specify which one was increasing to decreasing or which one was decreasing to increasing. You can just state both facts. We're not worried about if it was doing one versus the other for points of inflection. We don't care if it goes concave up to concave down or concave down to concave up. There is no differences between those ones. All right. You got to know that when I'm asking you just about, so you're using the graph. All right. Like I said, this is one of those questions on the AP exam. This is probably the one question on the AP exam where you need to get basically all the points. So when this free response question comes up, and they all look basically the same, people. They almost look basically the same. So if as long as you work and you practice and you make sure that you get your, you know how to do it, and you put in the work, you should be getting a lot of points. You should be giving max points. It is not uncommon for a student on this question to get 7, 8, or 9 points. 9 being the maximum. You can get at most 9 points on a typical AP exam question. Free response, you can get 12 points. 9 points. The average is typically around 4 points. 3 to 4 points is a typical average. A very high scoring average would be 5 points on a question nationally. This is a question that if you want to do well on the AP exam, you should be getting around 7, 8, or 9 points. If you want to pass the exam, this is one of those questions that, hey, this is just like the other 100 problems that I did in practicing of this type of problem. I've done this problem 100 times. The graph shifted a little bit, but it's the same graph. You should be able to get the answers and you need to not make mistakes. A lot of simple graph reading. That's what it comes down to. This graph, which is f prime, that's why I say it's so important, and I've been very anal about it. You need to say f prime, you need to say f, you need to say f double prime. And this is the reason why. This is the graph of f prime. You're looking when f prime changes from increasing, decreasing. You're looking when f prime is positive versus negative. You're looking when f prime is 0. Those justifications tell you what to look at. Delta Math is online. That's what I have for you for today. I will see you tomorrow.